fellow learners. This is Education Online program. I'm Teacher Rose Hezekiah. I'm here to present for you a lesson in chemistry for Senior 1 and 2. And our topic for today is about separation of mixtures. But before we go to separation of mixtures, let us have a short preview about what a mixture is. So, we have a mixture. A mixture is a substance. That is made up of one or more elements or compounds, not chemically combined. Not chemically combined. A mixture is a substance that is made up of either one or more elements or compounds, not chemically combined. That is, we have a mixture is made up of a result of the result of forming a mixture is not a chemical process. Because we said in a chemical process, usually we have new products. But when we have mixtures, no chemical reaction is taking place, and then we retain the nature of the materials that combine. So, we have examples of mixtures in our daily life. For example, we have air. Air is a mixture. Air is a mixture of carbon dioxide, oxygen, nitrogen, we have noble gases, and then could be helium, lithium, and then we have gas pollutants. So all these exist together as one body to give us what is known as air. So air is a mixture of carbon dioxide, oxygen, nitrogen, noble gases, and then we have gas pollutants. In addition to this, also we have water vapor. Then number 2, we have milk. Milk is also a mixture. Milk is a mixture of, we have carbohydrates, we can get fats in milk, vitamins, proteins, and mineral salts, and then water. So milk is a mixture of all these substances. We have carbohydrates, fats, vitamins, proteins, mineral salts, and water. We have bronze. And this bronze, mostly we use it for making medals. bronze is a mixture of copper and tin. So these are the few examples of mixtures. So, but our main topic in which we are going to focus is we are going to focus at at separation of mixtures. Why do you think we need to separate mixtures? We need to separate mixtures because there are situations whereby we need to use materials in their pure form, not mixed with other substances. Or sometimes we separate mixtures because we need pure substances. In our daily life, sometimes if you want to get good results, you need to have a pure substances rather than having with it impurities or combined with other materials. Then we have the method that is used for separating mixtures depend on the nature of the mixture. Depend on the nature of the mixture. For example, first, we have different processes of separating mixtures. Like, for example, we have filtration. This is one process of separating a mixture. Then we have decantation. We have simple distillation. And then we have also what is called fractional distillation. And then we have crystallization. We have evaporation. Centrifugation. Sublimation. We have magnetic separation, where we use a magnet. Then lastly, we have manual sorting. So all these are procedures used for separation of mixtures. We can separate mixtures using filtration, decantation, or simple distillation. And then we have fractional distillation, we have crystallization, evaporation, centrifugation, sublimation, magnetic separation, and then manual sorting. That is, we use our hands. Then the method that we use for separating mixtures depends on the physical properties of the mixture or the components of the mixture. And these physical properties are like solubility. We say the method that we select for separating a mixture depends on the physical properties of the components of the mixture. So these physical properties are like solubility. When we talk about solubility, we refer to whether the substances in the mixture are soluble or insoluble. We talk also, we look at density. That is the amount of matter in the substances that is present in the mixture. Then also another determining factor is the boiling point. In case of a liquid mixture, whether the liquid substances that are mixed together are of different boiling points. So if they are of different boiling points, we can easily separate them using simple distillation. Then lastly, we look at the miscibility. So the boiling points, for example, if we have a mixture of water plus alcohol. If we have a mixture of water and alcohol, we know that water boils at 100 degrees Celsius and then alcohol boils at 78 degrees Celsius. So when we use simple distillation, we boil them, then the alcohol will evaporate fast, leaving the water behind. So in this process, we can collect the alcohol and then we leave the water. So in this process, we can separate the two using boiling point. Miscibility, like water and oil. Water and oil are immiscible liquids. They don't mix totally. So we can shake them and then we can separate them using separatory funnel. Or for example, like we have water and alcohol. These are miscible liquids. They mix completely. You cannot differentiate between the water and the alcohol. But the water and oil, they are immiscible. So within the mixture, you will get a layer of oil because oil have got low density. The oil will be up and then the water layer will be. So you will have what? Two layers. You will have two layers of water and then a layer of oil. So these physical properties will be the determining factor for you to choose the method of separation. So, for example, if we start by filtration, when we want to choose filtration, filtration is applicable to liquids that are to mixtures that contain insoluble particles. Filtration is a process of separating mixtures that contain insoluble particles. Like for example, we have a mixture of soil plus water. So we know that soil will not dissolve in water. Soil will not dissolve in water. But if we have soil and water mixed together, and we want to separate the water from the soil, we use filtration, because the solid particles are insoluble inside the water substances. So, what are the requirements if we want to separate a mixture of soil and water? So if you want to separate a mixture of soil and water, first of all, we need apparatus. We need apparatus. That is the materials that we will be using for the process of filtration. So, one is we must have a beaker. And this is how a beaker looks like. Then we must have a conical flask. Sorry, this is round bottom flask. We have a conical flask. This is a conical flask. Then we have a funnel. This is our funnel. Then we have a filter paper. It is usually round. Then we start by, we pour our mixture into the beaker. If this is our beaker, we put our mixture here of soil plus water. Then we stir, that is, we mix it using a rod. This is called stirring rod. We stir our mixture. Then after stirring the mixture, we fold our filter paper and then we place the filter paper where the funnel is, to the size of the funnel. So after stirring the mixture, we use now the conical flask. We use the conical flask. We have our conical flask. We bring our funnel. We bring our funnel with the filter paper. And then we have our filter paper. Then after stirring the mixture, we pour the mixture in the beaker. Then we have the water will immediately come at the bottom. And then we have the soil will remain at the filter paper. We have, this is the funnel. and then this is conical flask. So what is left on the filter paper is called the residue. And then the water that comes inside the conical flask is called the filtrate. So after separation, we have two substances that is generated from one mixture. We have the residue. We have the residue. And then the filtrate. So up to this point, we have the residue. The filtrate is in form of suspension. The filtrate is in form of suspension. And a suspension is a liquid that contains small particles of solid spread throughout it. So we have the water in form of a suspension with the small solid particles spread throughout. Then we will leave the filtrate within the conical flask, that is the suspension. We give it time to settle. So once it settles, the solid particles will come at the bottom of the conical flask. Then once the solid particles come at the bottom of the conical flask, then we can use decantation. We now you bend the conical flask slowly. You pour the clear liquid, that is the water, and then you leave behind the small particles. So in filtration process, we first filter or we steer the mixture using steering rod. Then after that, we pour the mixture through the funnel that has got filter paper. Then the soil particles will remain at the filter paper and the liquid will pass through, which is the filtrate. So we have, at the first step, we have the filtrate and the residue. And the filtrate is in form of a suspension, that is a liquid that contains some particles of solid spread throughout it. Then we give chance for the filtrate or for the suspension to settle so that the solid particles come at the bottom and then the liquid material at the top. Then we decant, that is slow bending and pouring of the clear liquid water separating it again from the small particles. Then we get now our clear water molecule. So at this stage, we would already, or we might already separate it, the solid or the soil particles from the water. We separate the soil separate, and then we have the water. We have water separate. So this is simply a filtration process. So we said filtration is a process that we use when we have a mixture that contains insoluble particles inside a liquid. And then also for us to use filtration, we will look at the size. We look at the size of the solid particles. We look at the size of the solid particles. So when you look at water and soil, we can say that we look at soil, the mixture of soil and sand and water. The particles of soil are very small. That's why we use filter paper. We use filter paper. In other instances, we can filter using sieve. If we have a bit large particles or the quantity of the mixture is very large. For example, in our everyday life, there is a question that how do you separate tea from tea leaves? How do you separate tea from tea leaves? From tea leaf. So we separate tea from tea leaf. We use the sieving method. We cannot use filtration. So separation is based on the physical properties of the mixture. We say things like solubility, boiling point, density, and miscibility. These are the determining factors for you to determine which method you use for separation of the mixture. Dear learners, we have come to the end of our lesson. Bye-bye. See you in the next lesson.